to finish up this lesson on rhombi and trapezoids. Let's see. So we start with the definition of a trapezoid is a quadrilateral four-sided polygon with exactly one pair of parallel sides. So you can see from the picture the top and bottom, BC and AD with the little red triangles, are parallel to each other, but these other sides are not, like in a parallelogram. Just one pair of sides are parallel in a trapezoid. Then some special names of some of the parts. The bases are the two sides. We call them that are parallel, the bases, BC and AD. The legs are the two that are not parallel to each other, AB and CD. And this one's a little goofy. The base angles, the angles adjacent to the bases. All the angles are actually base angles. You know, if I color these red down here, these are the base angles for this base on the bottom, this base right here, AD. And they're not necessarily equal to each other. I'm just marking them. In an isosceles trapezoid, we'll see they are equal to each other. But the other pair of base angles for this base are up here in blue. Okay. Let's see what we got now. What's called a median. A median for a trapezoid is a segment that joins the midpoints of the legs of the trapezoid. So if you look at this leg right here, this is a midpoint. They show it's a midpoint by showing each of these pieces will be congruent if this is a midpoint. And on the other side, if this is a midpoint, these two pieces of this side of the leg will be congruent. So it's going from midpoint to midpoint. That is called a median. It is parallel to these other two sides. So all these two bases are parallel to each other, and so is the median. It's going the same slant. Then there's a special property on the size of the median and how it relates to these bases. In my picture right here, I'm calling this base on the bottom B1 and the length of this base B2. And here's MN. This mid segment goes from M to N. So the length of MN here, this median, equals the bases added up and divided by 2, or the average of these two bases. So we add these up and divide it by 2, and we'll get the length of this median. So we'll have a few problems like that. Here's some now. We have a trapezoid. And EF, they tell us, is a median. So we're going to be able to use that formula a little bit to solve for EF or some other things. So the first thing I do is when they tell me it's a median is I go ahead and mark, well, this must be a midpoint then. Then these two pieces are equal. And over on this side, these two pieces are equal to each other over here, not necessarily to these ones over here. Okay? So we look at example A, and we've got that information in there. And so they tell us AB, this bottom piece, this base is 25, the top base is 13, and they want to know EF. I put an X there. That's the median. So we use that formula and take the two bases, add them up, and divide by 2. So we get 13 plus 25 divided by 2, or 38 divided by 2 when we add them, equals 19. Okay, you can pause it if I go too fast. The B question. Again, I've got my little pieces marked here because this is still a median. Then they tell us this one, AE is 11 and FB is 8. So then they want to know from A to D. Well, if this piece is 11, the other one's piece is 11. And from A to D would be 11 plus 11, which is 22. BC is the same type of thing. They want to know this whole side. If this is 8, the other piece is 8, and 8 plus 8 is 16. So we got 22 and 16 there. The C question. This time they give us AB, the 29, the one base, and then EF, the median, and this time X is one of the bases, this top base. So the formula looks like this. The median right here, 24, equals the two bases added up and divided by 2. So now to solve this for that other base, the first step I'm going to do is multiply both sides by 2 to get rid of this division by 2 over here. So I divide that, I multiply that side by 2, it just cancels out that. I multiply this side times 2, I get 48 equals x plus 29 over here, because I got rid of that dividing by 2. So you got one more step, just subtract 29. And we get x, that other base, equals, let's see, 19, I believe. Okay. So that other one was 19. You could double check 19 plus 29, add them up and divide by 2, see if it comes out to the 24. Okay, pause it if you need it, or rewind it if you need to. I'm going to erase this right now and go to our next example. D. So in D, we've got a little tougher one. I've got all the information in here, A, B, median right here, EF is that much, and D. So we got a big algebraic equation. We'll set that up and solve it. So now we set up our equation using that median formula. The median is that middle, 5y minus 3 is going to equal the two bases added up divided by 2, so it looks like that. So there's the median, there's the base 1 right here, plus base 2 up there, divided by 2. So our first step is to multiply both sides by 2. You know, of course, when you multiply this side times 2, it's just going to cancel out that bottom. And then we'll put a 2 times all of this on this side. And with it canceled out over here, it's going to look something like this. Again, if I go too fast, you can pause or rewind. So there it is, canceled out. Over here, we're going to take 2 times this. We're going to have to use our distributive property here. So we're going to multiply this 2 times both of these things. And then over here, I'm going to combine like terms. 7y plus 1 more y is going to make 8. And then the numbers with the numbers 6 minus 2 is 4 there. So it looks like this now. Distributing it out, we get 10y and minus 6. And over here, we got the 8y and plus 4. So now we'll start solving for y a little more here. We've got y's on both sides, so I'm going to get rid of those 8y's, subtracting 8y's from both sides. That leaves us with 2y minus 6 on this side equals just the 4 over there. Next, I'll add 6 to both sides to get rid of that minus 6, so we end up with 2y equals 10. And then divide by 2, and we end up with y equals 5 there. Alright, whoops, I'll move that to the side. So there with all those steps, you can rewind if you didn't get them all. I'll go on to the next one. So we end up with y equals 5 there. The last example in this one looks a bit like this. Oops, forget all this stuff on the bottom. They give us the measure of angle EAB. So I go from E, and let me highlight it for you. You got to get used to doing this too when you're doing angles. E to A to B goes like this. The angle is this corner right here, 63 degrees. And then they want the measure of angle DEF. I'll use a different color here. Let's try some purple. D to E to F is this angle in this corner right here. Here's the two sides. And these are actually equal because we have these parallel lines cut by this transversal right here, and these are called corresponding angles. We learned before, and corresponding angles are congruent, the same. So that one would also be 63 degrees. Alright, let's see what we got next. Here's a basic problem where they want to know the median again. Here's the two parallel sides. This is the median. How do I know it's a median? They got these two pieces are equal, so this is a midpoint. These two pieces are equal, so this is a midpoint, and this is a median. So the median will equal what? The bases added up and divided by 2. So if we add those up, we get 58, and divide by 2, we get 29. Next, we have some new terms and definitions. We're going to find an isosceles trapezoid. We've studied isosceles triangles before. An isosceles triangle is a triangle that has two sides that are congruent. And this one is, yes, the two sides are those legs, those sides that are not parallel. Those will be congruent to each other, which means they're the same measure. You can mark them with congruent. These two pieces are equal. All right, so here's our example. It has exactly one pair of parallel sides, just like any trapezoid. This side is parallel to this one down here. We can do the little triangle thing. A little messy here because I'm in a hurry. You're about to come. Median is still the same. You know, if we have a median down the middle, yeah, those pieces are the same there. Those pieces are the same here. And actually, these legs are the same size, so these pieces will all be the same as each other. You know, since the whole sides are the same, all four of these pieces will be the same. And the formula for figuring out this, how long this median is the same. We've taken the two bases, add them up, and divide by 2, and that will equal the median. Again, the legs in a isosceles trapezoid are equal. This whole side equals this whole side, so when the median splits it, these pieces are all equal. If you draw the diagonals, we didn't talk about the diagonals in the other one because they don't do anything special, but in this one, in an isosceles trapezoid, they are the same size. And then the last part, this is a little confusing. The base angles are congruent, which means these base angles are congruent to each other. And these up here aren't congruent to those ones on the bottom, but they're congruent to each other up here. They're the same size up here. Okay, we'll see some problems where we deal with this. And then you'll see something special about these ones down here and up here, how they compare. And it's only in an isosceles trapezoid that this is true. So we look at this first example, angle ADC. From A to D to C goes like that. It's this corner is 54. The measure of angle BCD. BC, it goes from here to there to there. That's this corner, and we just found out those are the same. Let's see if I got it in here. Yep, there it goes. 54. Those are equal. Those bases equal each other. These bases equal each other up here. All right, let's get rid of some of this and look at the next one, BAD. So if we go from B to A to D, that's this corner, is 112. They want BCD. Let's use a different color here. From B to C to D, well, that's this corner up here, down here, okay? And these aren't the same. These are the same on the bottom, but not the same as those top ones. So we're going to call this X right now. So this would be X also, because these two are the same. And these two up here are the same, 112. How much should they add up all together? Well, we could use that formula we learned before, where you take the sum of all these interior angles in this four-sided figure will equal 180 times 4 minus 2, which ends up being 360 degrees in this quadrilateral. Whoops, 360. A little messy writing here. So then I know these should all add up to 360. So I have x plus x makes 2x, plus these two, let's see, that'll be 224 degrees. Equals 360. So we subtract the 224. and we get 2x equals, let's see, 6, 3, 136. Does that sound right? That's 30, 60, yeah. Divide by 2, and we get x equals 68. So this angle is 68, this one we wanted over here is 68. And what I want you to notice now, you can always solve it that way when you know one of those. We are good there. Another thing to notice though is these, when you add this one on the top and the one on the bottom, you're going to get 180 degrees all the time. So that's a shortcut for later. What else we got? The last one. On this one, we have the measure of angle ABC. A to B to C is 95. A to D to C, A to D to C is this angle right here. What is it? So again, we just learned that these two should add up to 180. You could do the, okay, this is 95, this is X, and do it that way. But I know that this a bottom and a top should add up to 180, so I take 180 minus 95, and I will get 85. Here we have an isosceles trapezoid. So remember, these legs are the same. And what do we got here? Angle EDO is 110. So from E to D to O is this angle right here, 110. And DEN, D to E to N is this angle right here. So we got a top and a bottom. It's 15x minus 5. Let's see if I did this right. I'm a little scared here. Nope, I did. So we learned the shortcut. These two will add up to 180. Okay, so I have the 110 plus the 15x minus 5 equals 180. And so we go ahead and solve that, combine the like terms. 110 minus 5 is 105. Then I'm going to get rid of that 105 from both sides and get that 15x by itself. So 15x equals 75, divide by 15, and we get x equals 5. Or the measure of that, yeah, I'm just finding x. Good. And I think there's one more example. Trapeze and isosceles trapezoid, PR. From P to R, that's one of the diagonals. T to A is the other diagonal. And what do we learn about diagonals? They're congruent in an isosceles trapezoid. So this one equals that one. So we write the equation like that. PR equals TA, where 3x minus 7 equals 20. We add 7 to both sides to get the 3x by itself, and then divide by 3, and we get x equals 9. Okay, that's it. So you'll finish up the practice. That includes that the trapezoids and isosceles trapezoids. Make sure which one you know. Are you dealing with just a regular trapezoid or an isosceles trapezoid that has a few more properties? Good luck.